Sehr geehrte Damen und Herren, liebe Kollegen, ich freue mich, dass Sie den Weg nach Nancy zu unserem französischen Kongress gefunden haben. Ich würde meine Ansprache gerne auf Deutsch fortsetzen. Leider verstehen einige meiner Landsleute kein Deutsch. So I would like to switch to English. So I am happy to introduce Professor Ulrich Trägner. Ulrich Trägner is presently head of the Chemical and Process Engineering Department at the University of Applied Sciences, Hochschule, Mannheim, and managing director of the Center of Excellence Virtual Engineering, Rhine, Neckar, in cooperation with John Deere Tractor Factory in Mannheim. Ulrich Trägner received his Master of Science in Mechanical Engineering for Ruhr Universität Bochum and his PhD in Environmental Engineering from the University of Illinois in the US. Previously, Professor Trägner worked at the R&D department of the BASF Chemical Company in Ludwigshafen, where he was a lead engineer in the field of environmental engineering. Throughout his professional life, Professor Trägner was always interested in model development and simulation. He is currently very involved in cooperation between NSIC is the School of Chemical Engineering in Nancy, and Hochschule Mannheim for the double degree in chemical engineering. He started a long time ago, I think about 25 years ago. I could give keywords of governing principles that sum up Professor Trägner's work. I would say multidisciplinary, modeling and simulation, German-French relationship, and I think, Professor Trägner is going to present a talk entitled I4.0, or in German it's Industrie 4.0, a formula for evolution. So you see, it's questioning. In France, this topic is sometimes a little mysterious, and I think French people would like to know how German engineers and scientists are preparing the future of their industry. So I think it's going to be very interesting. Professor Trägner, bitte. Yeah.
Thank you very much, Laurent. Thank you, Olivier, for this introductory words. Thank you for being here at this anniversary of the French Society of Chimie de Procédés. You already mentioned one birthday, or I already mentioned the 30th birthday. Yes, our cooperation between the NSIC and our university in Mannheim, the University of Applied Sciences, Fachhochschule Mannheim, is now also 25 years old. So this is already a tradition that connects our two institutions. My question was, why do the colleagues here think I'm competent to talk about the subject Industry 4.0? And I think Olivier already mentioned it. It is due to the fact that I am connecting in my present position, in my present job, several disciplines. I'm connecting, because I'm a chemical engineer and environmental engineer, I'm connecting chemical engineering field with the commercial vehicle sector, which is represented by John Deere. You can read it from the slide. We operate a joint laboratory in the field of virtual reality. And of course, being a professor, I'm involved into future education, or in the education of future engineers, and by the way, also a virtual reality specialist after a couple of years. In order to understand the terminology Industry 4.0, one has to go a little bit back in history. I will make this short. In the change of the century, one could observe that computers, the internet, and everything that had to do with it, software, was a fast growing market. And the Germans recognized that they don't have really a contribution to this. except for SAP, but SAP is not really a software factory in the sense of the Americans, of the Internet of Things. They were not contributing to this market. On top of it, Google and other companies tried to invade the German market by building vehicles that supposed to drive on its own. So they merged software with cars, and this is something that made the Germans alert. The car industry is a key industry in Germany, and this is why we found we need to do something against this. So car industry, cars is German, I have to admit, except for the diesel software we created. So, history continues, a little history. Why do we call it Industry 4.0? Of course, the first industrial revolution came with the steam engine and water power. With this new technologies, we increased mobility of people and of goods, and it led to the speed of production itself. The second industrial revolution was by reorganizing the work. The production was done now on assembly lines, and the introduction of electricity was supporting this fact and also brought wealth to the people. So the second big change in production in the life of people. The third level of industry was only limited now by the physical boundary conditions of the equipment. We developed software, we developed embedded systems, and they were helping to create or to use smart products, smart devices, but the limit was that they were not connected yet among each other. And this now leads to the fourth concept, the Industry 4.0. Here, all smart devices, I'm using some example later on, regardless of the data exchange, protocol, and talking, one follows now not an individual device, but really tries to connect everything with each other. So the idea behind Industry 4.0, at least this is my perception, means no boundaries between the machines and the software, no breaks. That means there is really communication possible among all the devices. Also important, and this changed the view for process control people, there is not really a hierarchy anymore in the organization of devices. You can say simply everything is totally connected. And some words, how our Chancellor Merkel would say, this is what we call Industry 4.0. I have to say at this point that the terminology or the term Industry 4.0 was never a research project, was never an official project of the federal government. It was a concept paper written by the federal government and later on established in the group that is called the Group of Industry 4.0. But this group, of course, consists logically of software producers, and this is why the interpretation of this terminology, Industry 4.0, has to be seen also under this aspect. I myself made practical experiences with this term, Industry 4.0, and I have to explain this, or I try to explain this with this matrix. It's clear when you do networking, you need a digital network. It's clear when you have digital data, you need to store them somehow. So cloud computing or storing in cloud is clear. So, but then you have this situation, you want to run smart factories. And if you want to smart factories, you need smart devices. So another term that's floating around in Germany is smart sensors. So the understanding of Industry 4.0 I want to explain as being a puzzle of a lot of things that were not connected yet in the past, but that can be connected with this idea Industry 4.0. I don't want to really explain all the stones I am showing here. I'd rather show you some slides where I can illustrate the effect of Industry 4.0. One is because we do have a cooperation with John Deere, is the topic of farming and commercial vehicles. And what I also learned is that when you want to deal with big and massive data, you have to have techniques to review this data, to review the concepts you are developing. And this I want to show with my next slides. I call this Farming 4.0. What's seen here on the picture? The farmer, of course, it's a John Deere, this is my sponsor, shows you a picture of the interior of a cabin of a farmer. And the farmer now in our days, or the modern farmer, uses data on the condition of crop, of the soil, be this humidity, be this the growth state, be this any attacks by weed or any attacks by bugs that are not wanted. At the same time, the new farmer or the modern farmer is connected to databases where he or she gets instructions of what to do with the field, with the field that has to be treated. And on the left picture, you really see that these are compartments. Something a human being cannot really tackle with. So you need modern software, you need the connection to databases, you might also need the connection to the chemical products that are used to accelerate growth or to do the bug control or the weed control. And so the farmer is very, very modern already. And my colleagues from John Deere always said, we do Farming 4.0 already, but we don't do Industry 4.0 yet. This is a surprise to me, but maybe I can show this later again. Why I also like on this picture here is pointing at this device. Most of you might recognize it. It's an iPad. And this is also typical for Industry 4.0. Industry 4.0 connects everything with everything. So if you want innovation to seep into everyday's life, you do this by using devices that are familiar to everybody. This iPad is nothing new for the farmer. He is using it for private reason as well for commercial reasons. And this is, I will say, also some really characteristic when you say you connect everything with everything. So you are not leaving, a product is not leaving the factory and is not connected to its customer. This is very important. Now, John Deere says, oh, we are not doing yet Industry 4.0, but in my understanding, yes, they do this in a cooperation with our university. We run a 5-sided a cave, and a 5-sided cave you have to imagine as being a cube of 3 times 3 times 3 meters, and people go in there and they are inside an image, and this image is 3-dimensional, and this 3-dimensional picture allows you to do certain jobs. In the past, John Deere was, when they developed their product, and the product is mostly concentrated or focused on the cabin, where the farmer is doing his operation and the control of the engine. In the past, John Deere was building 6 prototypes. The 6 prototypes were awfully expensive. When they built this, it took a lot of time to build physically the 1-to-1 models of what they wanted to design in the future. And when you had to do changes because the customer or the producer was not satisfied with the product yet, it took weeks to do the changes, and it took approximately half a year, up to 1 year and more, until you got a final plan for the new product derived from prototyping. This is now completely obsolete. John Deere is not using anymore the 1-to-1 models, or the 1-to-1 prototype. Uses now the digital images that come from the CAD system, the design system. And this can be reviewed 1-to-1, and this data, and now this is again the connecting thing, this data is also used later on for the production of the parts, for the assembling of the parts. And of course there are some legal aspects to the design of workplaces, and this is whether you are ergonomically correct situated, whether you have enough visibility forward, backward, sidewards of the tractor. We can do this now all in a cave, which is which is done with the techniques of virtual reality. Packaging in this background means when they produce a new cabin, they also ask the people from the production plant whether this is possible or not. So the integration of product into end user, into production is a key aspect of Industry 4.0. Of course, when you design a new product, be this a car, be this a tractor, you have to have ideas, you have to get input from the consumers, from the users. The user, consumer, can be studied itself. You can do modern marketing with the tools of virtual reality. The focus groups, key dealers are invited to see the new product, the new tractor that's coming out in 3 to 4 years. And they get already feedback of whether this new design can be a success, whether this is accepted by future customers. This feedback is awfully important, because if you have such a tool, the feedback and the corrections you can make, the development you can make, has a tremendous increase in speed. The other thing is, of course, you design a new product, a cabin, a tractor. You ask your customers whether they accept it, whether they can go along with, but then you need to produce it. Now we link these models to the factory planning and layout. Even there, and this is maybe because they say they are not that far yet, the factory planning is not really an integral part of the system yet, of the digital system yet at John Deere, but we have already started doing so. So product, customers, and production is what what is connected with the idea of Industry 4.0. Well, then, after learning, being a chemical engineer and of course also the director of this corporation, I was asking myself, how does this, how could this be that the car industry, the commercial vehicles are further advanced than we chemical engineers, than we process engineers? But then I remember that I was invited for several years now to the Digital Plant Congress in Würzburg, and they had actually the same idea. To introduce connectivity, to introduce the holistic view into process engineering. Here I learned, and I also found partners in Bilfinger, that being a chemical engineer, a process engineer, I should not look on individual things exclusively. I need to connect exactly with John Deere as well. So there is a creation phase for your products. There is a creative phase for the design of a plant. There is a pre-design phase for your plant. There is a pre-design thinking, a pre-design, a preview of your product, of your planning. And then don't forget, when we build products, and the products can be, in our case, either a chemical plant, it can be also be the chemical product. Our products live much longer than a tractor. Our products, a production plant, is living sometimes up to 40, 50. In BASF we had, I think, factories that run 100 years now and still in operation. During this life cycle, you need to redo, you need to review things, you need to do smart maintenance and revamping. These are all keywords you learn when you deal or when you try to consider the chemical production in terms of process life cycle or product life cycle. So with the time, we have more and more demand also from the chemical industry to use our cave, which is nothing else than the visualization of digital data. We use the cave with our customers or with people who do planning for reviews, plan reviews. I learned that the review process in this business is not that simple and not that trivial, and it's not that homogeneous as with cars or commercial vehicles. We do layout planning, exactly like John Deere does this with their plant. We do safety reviews. Actually, one can do with digital models, if available, the whole HSE, meaning Health, Safety and Environment Management Program. And you can do this in an extremely early stage, meaning when you do the planning with the proper digital system and with the help of visualization, you can tackle and speed up your planning, and you can tackle complexity which you could not handle before. But you need a digital model, at least a digital volume model. Think also of the situation where you design a GMP plant, good manufacturing plant, where you are not allowed to enter because you would spoil production. You could do reviews in a virtual space, and this is a possibility you did not have before. This slide I love to show because it connects also to one of my classes, which is industrial pumps. Sometimes it's hard to see. This is two things overlaid. This is a three-dimensional model from AVEVA, PDMS system, overlaid, and it shows you here in the center the pump. I hope you can recognize it a little bit. This was the planning stage before we got this plant built, this distillation column built. Actually, this distillation column and the location of this pump was done exactly according to the plan. And this down here is the image of a three-dimensional laser scan. And then you see the location is up here for the planning, for the planning stage, and this pump in reality is sitting down here. Interesting, if we would have had this three-dimensional tool when we designed the column, the distillation column, that was 12 years ago or even longer, we might have discovered that you cannot locate sump pumps that have boiling liquids coming into a pump. You cannot locate this directly on the same level as your reboiler. And I'm teaching this to my students, that you need to have a certain net pressure before the pump so that you don't have cavitation in the pump. And we had to learn it in operation after the third pump was gone and destroyed. We said, okay, this is a mistake in the design. We have to put the pump down at least to have a certain amount of pressure on the suction side in order not to run into the danger of cavitation. This picture is also taken from our small distillation plant, and this I want to use to clarify a little bit the term digital twin. Some people think, okay, if you take a three-dimensional picture of a real plant, you already digitalized your plant. This is a digital twin. Actually, this is just a small piece of a digital twin. The digital twin is much more. It is the program itself, it is the model itself, it is the PLT, the digital computation system, it is also the 3D laser scan, which can be used to control and do a documentation of reviews and revamps. So this is a useful tool to do so, but later on, when you would have a whole digital plant, you could do virtual startup, virtual training, safety training, and virtual field trip, as I mentioned, with GMP production. Well, we had John Deere, we had the changing things, the digitalization in the process industries, and I'm educating young engineers. What do I have to teach them in order they are fit for future plants, as you say, the production side of the future? So I call this EDU 4.0, and because it's one of my courses, I can talk about it in more detail. My course is called Plant Design or Plant Planning, and of course the specialist will immediately recognize everything. You need the process development step, you need the detail engineering, you need the basic engineering, you need project management, and these are already parts of the education system or already part of the course. But then there is this cave, then there is smart manufacturing, then there is virtual reality, then there is human-machine interface, then there is a product and process life cycle management, then there are communication platforms, and then there is also sweeping around in our days the term of big data. And all these things have to do or will have to do with plant design and with process design, but how to integrate this. This picture I will not have too long sitting up there because it contains no pictures, so it's not that sexy. So the professor, which is what I have to do, still have to teach the basics. This will still be 80% of our doing, but we also have to introduce the digital tools that are used in industry. We, for instance, use Pro2 for the thermodynamic modeling. We use COMOS to do the engineering programs. Lately, we established a course where we use the Aviva E3D, which is a PDM software package in our master course. But this is not the center. This is just tools. And this is what I want to say with this slide. The professor still has to be able to combine and to connect the basics, but also to introduce to new and modern tools. And the tools themselves, they are developing. They are more and more now integrating into each other, so you can exchange data between two-dimensional planning to 3 dimensions. Even there, one is working on, and if you have the 3-dimensional planning, you can do the reviews in caves, as we do have, and of course the communication with Moodle platform, OneNote and cloud computing has to be established at the university. So this was the non-picture part. Now I'm coming back to the wrap-up. What does a tractor and a sneaker, here it's the Adidas new shoe, have to do with each other? A lot. If I were talking in front of PLM, PDM specialists, I only would read one thing at the bottom. Actually, this is the wrong version. I would say the common thing is both are using Pro Engineer, Pro A, which is the product of PTC. And then I would not have to continue talking. But what does this mean? When you use it, or when you try to establish Industry 4.0, you want to use this technology to tackle jobs that have to do with a wide variety of customer needs, of customer requests, and you have to do this in a high number, not just 2 or 10 shoes. No, you have to do this with million shoes a year or a day. I don't know how many they are selling. And the tractor down here, you also see that this is a customized thing. It can be not a 4-wheeler, it could be an 8-wheeler if needed. And the production needs to do this without stopping in the production. It has to be online, assembled. So you need to have smart design tools connected with excellent PLM systems that can do these things automatically. And this is why I chose this picture. Both are using the same software backbone, John Deere and Adidas. Adidas is in the planning stage to tackle this problem. So let me conclude. From my point of view, I think that what comes with the Industry 4.0, you can discuss in terms whatever you want, whatever is a need of your company, and I think it's a logical step in the development. You will not be able to stop the digitalization of the production and the interlinking and the networking. Of course, there are still a lot of challenges. Actually, here is still written small and medium-sized companies, but at the final version, which obviously I did not pass along, I said companies in Germany are sometimes far behind in digitalization. There are some small companies that are very well developed. There are big companies that are not that developed in this field. And also you have to say goodbye to a concept when you say Industry 4.0 solves your problems. No, you still have to tackle the complexity of your products and the production yourself. Industry 4.0 only provides ideas and concepts, so never underestimate the complexity of your own products. Of course, when you talk about Industry 4.0, this is what I can talk about this and not be hit by a flash. There is no standard and no position and no agency that tells me what to do. Of course, also a big danger. Look at hacking, bugs, cyber attacks. the English health system was shut down due to a virus. Here the question of cybersecurity, the question of intellectual property, when you deal also with servers that are not only located in one country, you have to consider. Of course, every change is connected with worries, and the left picture shows that it went good because Charlie Chaplin survived this film. The right picture, this is me, and still it's me in the foreground of the picture, but in the background of my personality, Google and Amazon and co are collecting my data and analyzing this, and even my government is trying to jump into my data and using this for some reasons. And what's interesting, everybody who runs a Google phone, an Android phone, they already know not only what you want and what you like, they also know what you will do next. And this is finishing and say thank you very much for your attention.
Yes, thank you very much for this very nice and clear presentation. Behind the concept of Industry 4.0, looking at the education implications that they have, is there some standard for industry, standard for connecting, and also, by the way, I've heard that in Germany they have some special education training for Education 4.0 dealing with such a standard.
Well, there were good questions, and there are answers that are difficult to answer. First of all, Industry 4.0 is no standard. And Industry 4.0 is a concept for everybody. So this is the car industry and the commercial vehicle industry. And in my understanding, they are much further in integrating this concept of I4.0. They did it before, but for our jobs, plant design, plant planning, I know from BASF how difficult this is to introduce this. Even also the software products that are offered in the field of chemical production, chemical engineering planning is not that far developed. There are two tools I know of that might be successful if they are able to adapt to the needs of the customers. They are not coming from the chemical branch. So when we teach or when we using tools for I4.0, I have to look very in detail and with a big understanding of the software that exists on the market. Plus, I have to find people who are able to operate this. So I'm not able to run AVEVA E3D, but our new colleague will be able to do so. And this is why we decide to go into one direction with the software, but from the point of teaching, I say it's important to learn the concepts, whether I do this with a Siemens product or whether I do this with an AVEVA product. But the main target is to teach the young students that there is software that relates to PLM. So that's an individual thing, and you also need to have the equipment in your school and the personnel in your school to do so. This will be a challenge anyhow. So there is a lot of training going on in Industry 4.0, yes, I can say so, and but this Industry 4.0 training is always, you have to be careful, is always done by consultants who want to sell you some products. And if you understand this, you can have peace with the Industry 4.0 topics, because when you treat this as being a tool, as being a concept, then you still have the freedom to decide what you want to get out of this topic. So training exists, yes, there are a lot of conferences. I could have shown you slides where Industry 4.0 is connected to work, to production, to consumers, to health, to almost everything. And this is the good thing about this terminology, Industry 4.0. It brings people together to discuss the connectivity of a lot of things. But no, there is no standard. It's a challenge for every university to transform this into teaching. And yes, you find every consultant, open the internet, they offer you everything you don't need and might pay for.
Maybe another question? I have a last one. What do you think about the change? I think about the virtual life of the people, for workers, engineers. We see that, for instance, with students, even if it's not really virtual until now, but we saw that there are change in the, for instance, in our schools, students change. They can easily use smartphones, computers, but we know that we had to change to learn more deeply with. You see the link between different things. So, do you worry that something too much virtual can happen with the people in such a system?
No, the quality of virtual reality depends on the models you create. So it's still the job of the professor, of the designer, to decide what's good and what can be accepted. Virtual reality is also, like i4.0, just a concept, just a tool to do things in a smart way. It's not a value on its own. John Deere has experience with virtual reality now since more than 20 years, and we in Mannheim are the only one center that still is left over of as being a virtual reality center. And reflecting this fact, I find out that the reason is because we were very much integrated into the production, into the real life, and not detached from the real life and being a second life as you would expect when you're talking about virtual reality. It's nothing that's detached. No, it is an addition to tackle complexity. And yes, I have to tell you, last week I had a small conference with friends from the mid-size companies. They say the work market in Germany is the market for applicants. The applicants, the young people now dictate the companies how to employ them, not the other way around. And the young people, they bring their devices, and this is why I showed the picture with John Deere and the tractor. They bring their devices, and they want to be connected in the way they know it from private life. For young people, there is no big difference between this communication and the communication they have with the university. So the universities will have to adapt very quickly in order to be attractive. This will be a point to be up to date, to be sexy for applicants. If you had enough applicants, you don't need to do so. But in Germany, definitely the market is dictated by the searching, by the people who search jobs, and they really can bring factories, production, education, all closer to what's called the consumer world or the consumer electronics. It must be linked.
So, thank you. Interesting thing for notably innovation. You know what I mean. So, thank you very much.
Okay.